Chlorine is a gas and does not exist monoatomically. We will have to have another chloride ion losing another electron for us to have a molecule of chlorine. So we are going to have another chloride ion losing an electron to become a chlorine atom plus another electron. And now the overall here will be 2 chloride ions giving out 2 electrons and forming a molecule of chlorine plus 2 electrons. So this is what will happen at the anode. So this is the reaction at the anode. Now at the cathode, what happens? Now it is important to note that this number of electrons that have been given out at the anode must be equal to the number of electrons that are going to be accepted at the cathode. So sodium ion requires only 1 electron for it to go back to its initial state, which is solid state. But we have already given out 2 electrons. So we also require another sodium ion. To gain the other electron for us to have another sodium now in solid state. So the overall reaction at the cathode will be 2 sodium ions accepting the 2 electrons that have been given out at the anode for us to have 2 moles of sodium, which is solid. Now we also know that chlorine is not one of the friendly gases that we have. So it is important to note that this process is supposed to be carried out either in the open, you can carry it out in the open, or in a fume chamber. Because chlorine is a poisonous gas. So this is the equation at the anode and this is the equation at the cathode. We can also do another one. For the electrolysis of lead 2 bromide. The same setup will be maintained. And lead bromine gas is also poisonous. So it should also be carried out. The precaution that we need to observe is that we should carry it out in the open or in a fume chamber. So again, we have lead bromide here. It has got 2 types of ions. We have the cations and we also have the anions. The lead ions are the cations, whereas the bromide ions are the anions. So we start with the equation at the anode. And at the anode, which is positively charged, bromide ions are going to migrate there, or they are going to be attracted by that positively charged electron at the anode. So at the anode, remember bromine is a gas. So we have the first bromide giving out an electron to form bromine atoms and an electron. Again, being a gas, it has to lose another electron so that we have a molecule of bromine. So overall, we'll have 2 bromide ions giving us 2 electrons and 1 mole of bromine molecule plus 2 electrons here. This is a gas. This is molten, so it is in liquid state. So this is what is happening at the anode. And then at the cathode, lead ions are going to be attracted by the cathode. This charge of +2 tells us that before it became an ion, it had lost 2 electrons. So it will require 2 electrons for it to go back to its original state. So the number of electrons that were lost here at the anode are going to be accepted the way they are, since lead requires 2 electrons for it to go back to the solid state. So and that one becomes the equation at the cathode. That one becomes the equation at the cathode. There are also some more ionic substances that will undergo this process. Some of them include aluminium oxide. This one we shall do, I shall give it as an assignment for aluminium oxide, and then we shall start here in our next lesson, aluminium oxide, so that we see how aluminium oxide will be electrolyzed, how it will be, or how it will undergo electrolysis. It is important we know how to balance the equations that involve aluminium oxide. Now that brings us to the end of our lesson today, and it is important we have a checker or an exercise to see if we have gotten or if we have met our objectives. So I'm going to give a few questions. So we define, the first question, we are going to define some terms. Define the following terms. The first one is cathode, anode, electrolyte, electrolysis. You define those terms, and then you state particles responsible for electrical conductivity in sodium chloride. And then finally, write the anode and cathode equations during electrolysis of sodium chloride. So learners, that brings us to the end of our lesson today. So you attempt these questions. We will meet in our next lessons so that we can pick up from there. Thank you.